welcome to the another class of engineering mechanics. My today's topic is friction. Before starting and solving of the problem regarding friction, we have to go through some basic concepts regarding friction. Let's look down on the first image. This is a body rest in a horizontal surface. This is the attractive force. If the body is try to moves towards right direction, then automatically a friction force is generated on the left direction. This is the weight acts downwards, W, that is mg, that is equal to mg, and this is the normal reaction. So what is friction force? What is friction force? Experience indicates that there is always some degree of interlocking and wedge action between the contact and contact surface. Obviously, then when a block is made to slide over a surface, a force F gets automatically induced. This force acts in a direction opposite to that in which motion is short and offers resistance to the movement of a block. The resting force acts tangentially. The resting force acts tangentially to the contact surface and is known as frictional force. So this is friction force. Next is limiting friction. So what is the definition of limiting friction? It is the maximum friction force at the same time of impending motion. That is, when the motion is about to begin. When the motion of the block commences, the friction force drops to somewhat low value called the dynamic or kinetic friction. Dry friction, sometimes it is called Coulomb friction. It manifests when the contact surface are dry and there is a tendency for relative motion. If fluid friction manifests when a lubricating film is introduced between the contact surface. This is a dry friction and the fluid friction. Now this is very important, coefficient of friction, that is denoted by mu. And what is the coefficient of friction? It is the ratio of force of friction, that is F, and the normal reaction, that is R, between the contact surface. It is called coefficient of friction. It is denoted by mu. And this is angle of friction, that is denoted by phi. So angle of friction, what is angle of friction? Angle of friction is the angle which the resultant of normal reaction and limiting force of friction makes with the normal reaction. That is the concept, that is the formula, that is the relation tan phi equal to F by R, which is equal to mu. And angle of repose, the angle of an inclined plane at which a block resting on it is about to slide down the inclined plane. It is called the angle of repose. So after going through some basic concepts regarding friction, now we have to solve some problem regarding friction. Let's look down on the first problem. A block of weight 100 Newton is placed on a rough horizontal plane. If horizontal force of 60 Newton just causes the body to slide over the horizontal plane, the coefficient of friction between the block and the plane and the angle of friction is. These are the four options. So let's solve the problem. Okay, so this is assume this is the weight, this is the block, and the weight is 100 Newton and is placed in a rough horizontal plane. A horizontal force is applied, that is 60 Newton, just causes to body slide over the horizontal plane. Coefficient of friction, we have to find out the coefficient of friction and the angle of friction. So coefficient of friction, that is denoted by mu equal to F by R. Here F is the frictional force, that is 60 Newton. The horizontal force, that is the frictional force, that is 60 Newton, and the normal reaction R, what is R? That is the R. What is R? R is the weight. This R is the normal reaction, but what is that? W, weight is acting downwards, W, and which is equal to the normal reaction, that is R. So the value of W is equal to the value of R, so R equal to 100, so 0.6. The coefficient of friction is 0.6, and though this is the coefficient of friction. And now we have to find out the angle of friction. Angle of friction means the phi. We know that mu equal to tan phi, or this is mu equal to 0.6. You already calculate 0.6 equal to tan phi, so find phi equal to 30.96 degrees. So coefficient of friction is 0.6 and the angle of friction is 30.96 degree. So the answer should be D, 0.6 and 30.96 degree. This is the second problem. A box is given a push along a surface on which it rests with a velocity of 6 meters per second. If it stops after covering a distance of 5 meters, the coefficient of friction between the box and the surface is, G is given here, that is 10 meters per second square. So there are 4 options. So a box is given a push along a surface on which it rests condition. Velocity is 6 meters per second and it stops after covering 5 meter distance. So kinetic energy equals to the work done by the force of friction, that is half mv square is the kinetic energy, and the work done by the force of friction, that is mu mg into s. S is the displacement covered, that is the 5 meter. So half mv square equal to mu mg into s. We have to find out the coefficient of friction, that is mu equal to, from this equation, mu equal to v square by 2gs. V is already known, that is 6 meters per second. 2 into G is also known, 10 meters per second square, and S is the distance covered, that is the 5 meters. So after calculating this equation, we find out that the value of mu is 0.36. So the answer should be B, 0.36. This is the third problem. A heavy block of mass small m is slowly placed on a conveyor belt moving with a speed small v. If coefficient of friction between the block and belt is mu, the block will slide on the belt through distance. These are the 4 options. So a heavy block, what is the mass? This is a small m and placed in a conveyor belt. Conveyor belt, the speed of the conveyor belt is small v. Coefficient of friction is mu. So block will slide on the belt through the distance and we have to find out the distance. So the block will act it upon the frictional force, that is mu, F equal to mu into R, mu, and the R from in space of R I'm writing mg. So it will cause an acceleration, that is A is the acceleration, equal to F by m. What is that? That is mu into G. So the block slides on the belt till its velocity becomes small v. So v square minus u square equal to 2as. We have to find out the value of the s, the displacement. What is the distance covered? So v square u square u is the value of u is 0. So 2 into as in place of a we have to write mu g and s. So after calculating this equation, s equal to v square by 2 mu g. So the answer should be D, v square by 2 mu g. This is the fourth problem. A weight of 4.9 Newton rests on a rough horizontal plane that has coefficient of friction mu equal to 0.5. If g equal to 9.8 meter per second square, the smallest horizontal force that gives the weight and acceleration of 4 meter per second square is nearly. These are the four options. So weight of 4.9 Newton rests on a rough horizontal plane, and the coefficient of friction already told, that is 0.5. G is already told 9.8 meter per second square. So we have to find out the value of the smallest horizontal force. Okay, so from this problem, P minus F equal to MA. P minus F equal to MA. In space of F, we write down mu R. In space of M, write down W by G. And from this line, P minus mu W, because normal reaction is equal to the weight of the body, W by G into A, and after calculating and after putting the value, P equal to, it nearly 4.45 and it is 4.5 Newton. So the answer should be 4.5 Newton. This is the fifth problem. A uniform flexible rope of length 60 meter is partly lying on a rough table and is partly just hanging across the edge of the table. If the coefficient of the friction between the table and rope is 0.2, the maximum length of rope which can just hang is. These are the four options. This is a very common problem. This is the table and this is the rope. Okay, so let's assume the hanging portion of the rope and the length of the rope is x, which is in hanging portion, and the length of the rope is L minus x. The total length is L and this is the x, and this portion, the length of this portion is L minus x. So if W is the weight per unit length, then for this condition, mu equal to mu into L minus x into W equal to x into W. Mu is the coefficient of friction, which is 0.2. L is the length, that is 60 meter. We have to find out the x. So x equal to 10 meters. So the maximum length of the rope should be 10 meter. This is the sixth problem. A body of weight 120 Newton rests on a rough horizontal plane surface mu equal to 0.3 and is acted upon by a force applied at an angle of 30 degree to the horizontal. The force required to just cause the body to slide over the surface is about. So we have to find out the value of P, that is the force required to just cause the body slide over. Okay, so let's assume this is the body and the weight of the body is 120 Newton, that is in rest condition on a rough horizontal plane surface, and the friction between the rough horizontal surface and the weight and the body is 0.3, and acted upon an angle of 30 degree into the horizontal. So we have to find out the force required to just cause the body slide. So from the first, this is the first equation, F equal to P cos theta. From this condition, this is the first equation, F equal to P cos theta and R equal to W minus P sin theta. This is the second equation, and we know that F equal to mu into R. So from after equilibrium, this is the equilibrium condition. So equilibrium condition, so we equate the both equations. So P cos theta by mu equal to W minus P sin theta. So we have to find out the force. So P equal to mu W by cos theta into, plus mu sin theta. So mu, what is the value of mu? The value of mu is 0.3 here. So 0.3 into W. W is the weight of the body, that is 120 Newton. So into 120, angle 30 degree to the horizontal. So cos 30 degree plus mu 0.3 into sin 30 degree. So after calculating this equation, 35 Newton will be obtained. So the answer should be 35 Newton. That is the option C. This is the last problem for today's class. A mass of 200 kg is resting on a rough inclined plane of 30 degree. If coefficient of friction is 1 by root 3, the least force acting parallel to the plane to keep the mass in equilibrium is. These are the four options. Let's look down. This is the first condition, this is the second condition. In the first condition, the movement down along the plane. So this body tends to move down along the plane. So frictional force is generated in this direction. So the force is P2, and this is the normal reaction. This is the W acts downward, W equal to mg. This is mg sin theta. So this is a condition, this is the first condition, that is movement down along the plane, and this is the second condition, that is movement up along the plane. So if in 30 degree angle, if we try to lift up the body, then the frictional force is generated in this direction, and the W is act downwards, and this is the normal reaction, that is equal to mg cos theta. So for the first condition, let's look. Let's assume this is the first condition. So we know that is F equal to mu R. Okay, so in the first condition, P1 is the force required, P1 equal to mg sin theta. For calculating this condition, P1 equal to mg sin theta plus mu mg cos theta. So what is the value of m? That is 200 kg. Sin theta, g equal to 9.8, g equal to 9.8, g is given 9.8 meter per second square, g equal to 9.8. If g is not given, then you can put the value 9.8 meter per second square. So 9.8 into sine, that is the angle 30 degree, sine 30, and the value of mu is 1 by root 3. So plus 1 by root 3 in space of m, mg, m is 200, g is 9.8 and cos 30, and the value is 1960 Newton. But we have to find out the least force acting parallel to the plane keep the mass equilibrium. So what is the value of P2? P2 is mg sin theta minus mu mg cos theta. After calculating, this is 980 and this is 980, so 0. So there is no force is required actually. No force is needed here. So the body will be just held on the plane when its angle of inclination is 30 degree. So obviously the 30 degree is the angle of repose here. That's for it today. Hope we will meet in another class of this subject. Thank you.